Recently, a major milestone was quietly reached in the world of science. The human brain, one of the most challenging and complex structures in neuroscience, has been an obstacle for researchers for a long time. Neuroscience itself is one of the toughest fields, and understanding how any brain functions, even without looking at the human brain, is a major challenge. The real struggle has always been figuring out the billions of connections between countless neurons, each made up of different neuron types. For a long time, understanding such complexity seemed like nothing more than a dream. Up until recently, scientists couldn't even fully grasp the tiny brain inside a fly's head, much less the human brain. But now, that has all changed. Recently, scientists published an article in Nature announcing a major breakthrough. They have successfully mapped the entire brain of a fruit fly, including all its connections. While this might not sound impressive at first, it is actually a revolutionary step forward. Once you realize how similar the brain of a fly is to a human brain, you'll understand why this achievement is so important. This story started back in 2013, when a neuroscientist named Davy Bok and his team at the Janelia Research Campus of the Howard Hughes Medical Institute in Maryland, USA, came up with a chemical solution that could preserve the brain of a fruit fly. The brain of this adult female fruit fly, which is about the size of a poppy seed, was stored in this solution for 5 years, from 2013 to 2018. In 2018, the team was ready to slice this tiny brain into 7,050 slices using electron microscopes. They then took 21 million photographs of these sections. Just imagine cutting the brain of a fly, no larger than a seed, into thousands of pieces and taking millions of pictures. It sounds almost like magic. These extremely detailed images were made publicly available, and this sparked a new idea. Researcher Sebastian Sung posed the following question: could this data help us map the human brain down to every neuron and synapse? Mel Murthy, another researcher, explained that at first, the idea seemed impossible. There was too much data to process, and no one had ever attempted to create such a complete map of a brain before. Thus began a massive and ambitious mission. The researchers initially tried to recreate the brain of the fly using the data they had, with the help of artificial intelligence, AI. However, no matter how advanced AI was, it wasn't perfect and made some mistakes. In this case, human labor was still necessary to correct those errors. This is where a group called Flywire was formed. The goal of this consortium was to bring together hundreds of volunteers to manually check and fix the brain map, known as the connectome. Volunteers from around the world sat in front of their computers, analyzing every single detail of the fly's brain like they were solving a giant puzzle. Thanks to the dedication of these volunteers, who worked hard to catch even the smallest errors that AI had missed, the team was finally able to create the most complete brain map of any organism to date. The brain they mapped was no bigger than a seed, yet it contained close to 140,000 neurons. Out of these neurons, 8,453 belonged to different neuron types. These neurons were linked by more than 54.5 million synapses, or connections. Imagine the level of complexity involved in mapping the brain of a tiny fly. This discovery helps us understand why the brain is considered the most complex structure in the universe. To put this into perspective, if we took all the nerve connections in the brain of this one fruit fly and stretched them out, they would extend more than 150 meters. That's longer than 4 blue whales lined up nose to nose. And remember, this is just from the brain of a single fly. Now, imagine how long these connections would be if we tried this with the human brain. It's almost impossible to comprehend. The significance of this study, published in Nature, cannot be overstated. As Clay Reed from the Howard Hughes Medical Institute mentioned, this achievement is a major milestone. Why? Because no brain structure has ever been mapped with this level of detail before. Previous attempts, like mapping the brain of a sea urchin larva with 177 neurons, or a roundworm larva with 302 neurons, were much smaller projects. Last year, scientists successfully mapped the brain of a fruit fly larva, which had 3,000 neurons, but mapping the brain of an adult fruit fly was a much larger and more complex task. You might now wonder, why should we care about mapping the brain of a fly? You might be surprised to learn that humans share about 60% of their genetic structure with fruit flies. Even more surprising, 75% of the genes that cause genetic diseases in humans are also found in fruit flies. So, by studying the brain of a fly, we are actually taking a huge step closer to understanding our own brain. If this still sounds surprising, consider this. Fruit flies can get drunk like humans, they can sing, and they even stay awake after consuming caffeine, just like we do. These behaviors show that there are important parallels between how the brains of flies and humans work. As Sebastian Seung from Princeton University said, "If you can truly understand any brain, it will teach us something about all brains." One of the most exciting results of this research is that scientists have successfully created a computer simulation of the fly's brain. This virtual brain can predict how a real fly's brain will respond with more than 95% accuracy. For example, it can predict how the fly's proboscis, its mouthpart, will move in response to sweet or bitter tastes. In other words, this is a fully functioning, digitally recreated brain. Thanks to this brain map, scientists can now better understand how a healthy brain works. This could also help provide important clues for treating brain diseases. In this study, scientists discovered 4,581 new neuron types. They also learned more about neurotransmitters like dopamine and serotonin, which play key roles in emotions and mood. So what's next? Scientists are now working on mapping the brain of a male fruit fly. They are also beginning the process of mapping the brain of a mouse, which is about 1,000 times larger than the brain of a fruit fly and has far more neurons. And when it comes to the human brain, how many neurons are there? Get ready. There are about 86 billion. These neurons come in thousands of different types and are connected by around 100 trillion synapses. If we laid out all the neurons in a human brain, they would stretch around the Earth 4 times over. Now imagine if we combined all the synapses from the 8 billion human brains on Earth. The total length would stretch far beyond our solar system and could even reach Alpha Centauri, the closest star system, and back several times. This shows not just the physical size, but also the potential for human creativity and intelligence. This is why the brain is considered the most complex structure in the universe. Think about this. Right now, you are using this powerful organ, your brain, to understand these words, make sense of these sentences, and process all this information within seconds. The brain's power and potential seem limitless. As Davy Bach, one of the leading scientists in this study, said, "We're not done yet, but this is a huge step. Who knows? Maybe studying the brain of this tiny fruit fly will one day help us unlock the mysteries of our own brain." Who knows where science will take us next? But with each new discovery, we move closer to understanding both the universe and ourselves.